All right, so today we're going to talk about SQL and spatial database operations. So I just updated this recently, the presentation. So if you downloaded it, within the last, I think it was 2 hours ago, I updated it. So if you downloaded it before then, it's a little bit different. So a couple things about this lecture. It probably fits better back when we talked about spatial joins and overlays, but in order to get this to work, in order to do what we're going to talk about today, which is spatial SQL, spatial structured query language, you can do it in ArcGIS, but you need to have an enterprise database on the back end. In other words, you need to have a software tool, another software tool that will support doing this type of analysis. And the last time I taught this course, I set one up in the cloud on Amazon Cloud, and it didn't cost a whole lot, but it didn't perform that well. So I'm trying something different. So today I'm going to teach these concepts in QGIS. So in order to get this, I had to install QGIS on all the machines, the latest version of QGIS. And so all the machines should have QGIS on them, and make sure it's QGIS 3. Some of the machines may also have QGIS 2 on them, because they all used to have QGIS 2. So I installed QGIS 3 on all the machines. So if the lab and the examples that I'm going to be doing in today's class all are going to be in QGIS. Who's used QGIS before? I don't even know what QGIS stands for. Well, I know what GIS stands for, but I don't know what the Q stands for. But QGIS is a open source GIS software package. And it is supported by the open source GIS software community, which is actually pretty robust. There's a lot of good open source software out there in the GIS world, and historically the desktop environment was one of the weaker components of that. So but QGIS over the last, I'd say, maybe 10 years has really come around, and it's a good product, and it's free, so you can download it on your computer if you want to for free. There is a way to do what we're going to do today in ArcGIS Pro, and I'll kind of talk about that. But the weakness is that you can't just do it with any file. You have to do it with an enterprise database. So it requires at least setting up a something that requires additional software and hardware. Now, there are a number of options. You don't have to do commercial. So you could set up an enterprise database using an open source software package called Postgres, and then you could do it. And that's open source software, and so you can do that. But all right, so let's talk about what this is. This is basically an alternative way to do overlay and spatial joins. It's framing overlay and spatial joins in terms of using a language rather than using a tool. So there's a language that's already developed for talking to databases, and it's called Structured Query Language, SQL. And it's extending that language, Structured Query Language, so that it can also communicate spatially. And so that's what we're going to talk about and learn today. So this is really like another way to think about about spatial joins, overlay, and that concept. Rather than doing a tool-based approach, it's a language-based approach. And even the tool-based approach brings some stuff in. Okay, you'll notice in lots of the tools you can add a where clause. Well, we'll learn a little bit about what a where clause is today. A little bit more about that. Okay. So the first thing that I want to talk about is that spatial data is really the data we've been dealing with. Remember, it's really attributes paired with spatial information. And that spatial information is often modeled just as another attribute of that entity that's being modeled. So if we're modeling a building, its extent is a spatial attribute of that building, as well as other things like maybe its year, or the number of rooms, or the capacity. Those are other attributes, and one attribute could just be its shape, the geometry. Okay. Right. So that's what we're talking about. We need to make sure we understand that concept, because when we talk to our database, and when I mean database, I just mean rows of information organized into tables. When we talk about our database, what we're trying to do is get records out of the database. That's what the structured query language is going to do. It's going to allow us to retrieve records based on criteria. All right, so some people would argue that what makes a GIS is actually one of the things that makes a GIS is the ability to analyze geographic data. And the model that a software package like ArcGIS Pro has taken is that most of that analysis takes place using what they refer to as tools. So it's kind of like GIS is a toolbox for analyzing GIS data. And if you learn the tools and what they do, you'll be able to analyze the data better. In other words, you'll be able to go from a question to which tools should I use, executing those tools, and get an answer. So today, when we talk about structured query language, it's very similar, but we're removing the concept directly of tools. It's just one tool, and that tool is we go from our question that we need to answer, that we need to ask, to turning that into a spatial structured query language question. So in other words, we need to translate that from plain English to SQL to getting our answer. So it's a translation problem, not necessarily developing an algorithm. Sometimes we do have to answer multiple questions to get to our final answer. So in a way, it's really, really similar. It's just that there's not a big old list of tools. There's just a single tool, and that tool helps us to. Is a language, because computers don't really understand natural language. Like computers wouldn't understand if I said, for example, in the lab we're going to do this. How many subway stations are in each neighborhood? Computers don't understand that. So we need to turn it into a structured language. Another word for that is a formal language for passing that off to the computer. Okay? And this language is actually complex enough that you could write kind of big computer programs. So this is not usually how it's done. Usually you execute single statements. You give it a single statement, and what it's doing is passing that off to the computer, and you're getting back a bunch more rows. And those rows can have geometry. Okay? So that's that one. Okay, so I mentioned that the data that we're going to deal with, the data we have been dealing with, is really stored in groups called tables. Sometimes we could refer to them as relations, usually refer to them as tables. So in GIS, when we say a layer, a vector layer, is really just a table that has a special column. And that special column is the spatial column. But it's still just a table. So tables consist of rows, records, columns, or fields. So rows or records is one word for this way. Columns or fields, another word for this way. Rows are usually identified by a unique key. And columns can be linked to other tables with similar columns. In other words, if we have a county's data set, sometimes there'll be a unique ID. Sometimes that might be the federal ID for that county, which is the FIPS code. And we could relate that table, that spatial table that has a spatial column, to another table that is the socioeconomic information for that county. So in a good database structure, the schema is critical. The schema is how the tables are laid out. In other words, it's the rows, the columns, the names of those columns, and the data types for those columns. So all the data in a row should be dependent on a key, and the whole key and nothing but the key. So in other words, the data in a particular table should be unique to that particular key. All right, so most of the time, the GIS analysts and researchers are working with existing databases. Now, that's not always the case. Sometimes we actually need to develop and create the databases, but there's lots of existing data out there. So oftentimes we still need to know what the schema is. In other words, we still need to know what the fields are and what data types there are. So today we're going to concentrate. Well, actually, we're going to concentrate on extracting data. In other words, we're going to concentrate on asking the database questions today. That's why I have this highlighted. But SQL can do these other things. It can change data, it can insert data, and it can delete data from a database. There are methods for doing that. But we're going to focus on extracting data. In other words, another way to say that is asking questions of our database. All right, so SQL stands for Structured Query Language, and a lot of times it's pronounced SQL. It's a standard way for working with relational databases. So SQL is a language that's implemented in lots of databases. That's the best way to say that. And so although there are standard organizations that are saying, okay, this is the way SQL should work, unfortunately, in practice, there are different databases that will have slightly different words that mean the same thing, or one might be lax in terms of capitalization. One might have, like I said, a slightly different command to do a particular operation. So you oftentimes have to read the documentation. If you get an error, read the documentation and see why it's having a problem. So, in the examples today, the SQL keywords will be capitalized, but typically, in most implementations of SQL, case is not important. It's not case sensitive. It's different. Not all computer programming languages are like that, but SQL is different in that it doesn't worry about that unless you're actually referring to, like if you're trying to find a particular record in a database and you're asking it a question about, you're saying, okay, I want to find the county named Lamar, and if you do all Lamar in all caps, that's different than the actual words in the language. All right, we do need to review data types. So in SQL, there is the concept of data types. Every column can have a data type. Here are some of the basic data types. We've got basically characters, strings, integers, real numbers, decimals, and you can actually have columns that just represent true or false, Boolean columns. It's not an exhaustive list of all the different data types, but those are a lot of the different basic data types. Really what you need to be concerned with is it a string, is it a number, or is it Boolean? And if it's a number, there are floating point numbers and integer numbers. So if you're ever doing any formulas on those integer numbers, you want to make sure that you get the right answer. There's not a lot of they're not rounding when there shouldn't be rounding. All right, so let's talk about asking databases questions. So when we ask databases questions, this is the basic recipe for doing that. So extracting data always is what we call a select statement in SQL. Okay. So when we say select, we're asking to extract data from one or more tables. It's not just, we're not operating on a single table. We could be, but we could also be operating on multiple tables. Now, oh, sorry, this isn't the recipe. These are actually the different types of commands. So select is for extracting, and that's what we're going to focus on today. But if we want to change data, we would start with update. That would be the command we would start with. Recipes on the next two. So select, update. Insert is for adding new data into a table. Deleting is for removing data from a table. And then there's a few others, create temp and copy. Create temp creates a temporary table. Copy sends the contents of a table to a file or another table that's usually a persistent file on disk. Okay? That's what copy does. So today we're going to focus on select, the select statement. So probably 90% of work in SQL is asking questions. And so I would say that the select statement is the most commonly used one. If you actually want to use it to create data, there are other tools for doing that. So sometimes those are used more often. ArcGIS, we know we could create data in ArcGIS. We can create new tables, add rows and columns. But you can do it using SQL. So select statements. You can't harm data using a select command. So if you're just using a select statement, you're not going to harm any of the data. Whereas doing a update or an insert, you could mess up the data. All right. So select statements can go from really simple statements to being almost incomprehensible. They can really have a lot of data. I mean, sorry, really have a lot of commands nested inside of them. Just make sure I was recording. All right, so this is the recipe here. Select statements are broken up into what we call clauses, and not all of these clauses are required for every single statement. So we're going to go through and look at these and talk about which ones mean what they mean, what each of them mean. Okay. So we're going to look at a few simple queries as we do that. So we've got our basic select statement. This is the recipe that I was talking to. See, it kind of looks kind of like that slide I said was the recipe. Sorry. So this is actually the recipe I was referring to. So the way that it works is we dispatch a select statement, and after the select statement, we list the columns that we want to see in our result table. So the result is always a table. We're asking questions of a table or tables, and we are getting a result back that is a table. So we need to list the columns that we want in our output table. Then we need to list what tables that we want to work with. after we say from. So the tables that currently exist, we could say select column A, column B from table A. And then where is used as a condition to limit selection. In other words, we can use a where statement to make a selection. And you've used where statements before. You've run the select tool, right, in ArcGIS Pro, or what other tool uses a select statement? Let's see, I can't think right off the top of my head, but there are other tools that use a use a where statement, a where clause, where you're taking out certain records. So if you said where population is greater than 500, then you're asking for it to return only those rows from this table that have the population greater than 5,000. Then you can group the data by a certain column, the value in a certain column. This has the effect, it's kind of like doing a summarize by. And then having limits group by. Order by and limit are only used to sort the data and to actually return, like let's say you're running a query that you know is going to be really, really long and return thousands of records and you just want to make sure it's working, then you can limit the number of rows to extract as the last option. Okay, this is basically the same thing, just showing it in a different manner. So let's actually start off by showing you what I'm talking about here. So I'm going to open up QGIS, and I could use the data that I was going to use for the lab. Yeah, let's just do that. Okay. But it might be nice to see some other data. Yeah, here I'll just use. I'll do that as another example. So I'm just going to go to Maris, and I'm going to download. Let's see, census. 2010 is. Hey, we're gonna have a census next year. So we got 2010 county level population and housing data. I'm going to download this. I wonder what format it'll be in. Probably shapefile. Yep. Okay. So I'm going to take this, copy it. I'll put it in C temp, and I'll call this spatial SQL. All right. So I extracted that shapefile out, and a shapefile is just a table. Remember? So it's a layer. So here I am in QGIS, and there are actually a few different ways to add data into QGIS. But the way I like to do is just under layer. You can say add layer, and then you could choose to add a vector layer. Now, some of these can also be vector layers. Like you could add a feature layer or ArcGIS feature server layer, but a vector layer will allow you to add a shapefile. If you have ArcGIS Pro installed on your computer, you can also add geodatabases, file geodatabases in. Okay. All right. So, but I'm going to hit File here, and then I'm going to navigate to my shapefile. I put it in C temp spatial SQL class, and I choose the shapefile, the SHP file. So say Open. Okay. And now all I have to do is hit Add. QGIS will ask you if you want to, or not ask you, but it'll require of you to specify what geographic transformation you want the data in. And it's okay just to hit the default. So what this is telling us is that you're importing some data that is in EPSG 3814, which happens to be Mississippi Transverse Mercator, and that it's going to display it in EPSG 4362, which is latitude and longitude. And that's probably fine. Let's see what the other choices that they put here are. It looks like it's pretty much the same. They all look like they're the same. So.
What data set did you use?
I got the Mississippi county level population and housing. So I downloaded this one right here. Okay. So I'm going to say OK, and I'll hit close. And you can see that here is the data. It's a pink color. I can open up the attribute table by right-clicking on it and saying Open Attribute Table. And then I have all of these attributes, and I should have a lot of census data. So I got census data. This is probably, look at all the names are like horrible, right? You can't tell what they mean. But you can look inside of this little Excel file. So it'll tell you what each one means. So the total universe population is P0010001. So if I go back here, this column right here represents the population. Okay. All right, so let's do a simple SQL query. I just want to I just want to find out which counties, I just want to show on the map the counties that have a population over 20,000 people. Okay. The way that this is done, the way this is implemented in ArcGIS, in QGIS, is to use what's called a virtual layer. In ArcGIS Pro, it's called a query layer. So it's similar. Okay. So it's a virtual layer or a query layer. Here it's called a query layer. So you can go layer, add layer, and then you go to add, edit virtual layers. All right, so I have Mississippi there. And then here, what I can do is set up any layers that I want to be involved in any query that I make. In fact, you can put 20 layers in this embedded layers thing. These are the layers you want to work with, right? Right now, I only have one layer. So if I hit import, it'll show me that one layer, and I hit OK. So now I can work with, I have to select it. So now I can work with that. In my query, I might want to give it a more simple name because I don't want to type county 10, pop H, whatever. I don't want to type that. And so I can give it any simple name. Sometimes I give mine really simple names because I'm so lazy. But so I could just go C, but I'll just go CNTS for counties. So now when I refer to it in the query, it's going to be referred to as CNTS. I don't have to type out the full name of that in the query. Does that make sense? And then finally, I have the ability to specify a unique identifier column, but I don't need to. I usually leave this blank. And then I also have the ability to tell it which column represents the shape or the geometry. I usually leave that blank unless it's having a hard time finding it. It is possible to write a query where the result table actually has two columns that represent geometry. And so sometimes you have to tell it which column you want to display on the map. Okay. But let's just start with a simple query where that's not going to be the case. So we always type in select. And again, we don't have to capitalize it or lowercase it. The actual keywords aren't case sensitive. So here I can select which attributes I want to include in my output table. I don't have to include them all. So I could say, let's say I just want the county name and I'll say I want the county seat. What is that? CO underscore. See how it's helping me put the right the columns. And I also want that P00. Yeah. So now I have that one. Another thing that SQL allows us to do is rename the columns. So I might not like the way that column is called. So I could put a comma, and I mean not a comma. I could just say as population. And now in my output table, it's going to be called population. That's pretty cool. All right. So now I can use the from statement. From. And then I specify here what table I'm going to use. So what table am I going to use? There's only one table. What's the name of the table? CNTS, exactly. All right. Now, here, if I go back to my recipe, so I'm right here. Select from where. Let's do a condition. Actually, let's first just run this. Okay. All right. So to actually run this, what I need to do, I don't actually have to do this part, but this is the name that it's going to give the new layer that I'm just creating. I don't know why they didn't put that at the bottom. They put it at the top, and they didn't make it very big. I don't like how big it is. I mean how small it is. So I'm just going to call this. I'll call this pop counties because it's really going to be the exact same thing. It's just going to include just the population. Right? So now I'm going to say test, and it says it's great. And I say add, and it's added a new layer. See that new layer that it added? Population counties. There's no symbol next to it, and there's no way to turn it on and off. So let's look at, if I open up the attribute table, look, it's got exactly what I told it that I wanted. It's got the county name, the county seat, and it now has population labeled instead of P001. It doesn't have any of the other fields. Why don't you think that it has a way to turn it on and off in the attribute table?
There's no shape column.
There's no shape column, exactly. So QGIS, it implements everything, and it always uses geometry as the name of the shape file, as the name of the shape information. And I know that on disk it's actually called shape, but just remember in QGIS, it doesn't matter what the geometry column's called. It's called geometry. You need to call it that. So if we want the geometry column, we need to say we want it. Geometry. So now we have our geometry, our column name, we have all that, and we can hit add again. And what this will do is it'll first warn us if we want to overwrite it because we haven't changed the name. And we can say yes, because we do. And now that one has symbology. Can open up the attribute table and see it. Okay. All right. So how many features are in this? There are 85 features. So let's select out only those counties that have a population of greater than 20,000. So there, what we have to do is say where, and then we need to give the name of the field. The name of the field is P0010001. Sometimes people get confused. They say, I named the field population. It actually doesn't care that you named it population. It wants to know what the name of the field is in the original data set. So you need to give it that name, not population. So where population is greater than 20,000, that should be 20,000. So that's my query with the where clause. So I could go up here and rename this pop counties GT20K. Okay, greater than 20K. Now I could test it. No error. Sometimes you might get an error. Like if I had like put this in quotes because I thought that the data was a string or something, and I said test, then it would. Oh, it still says. Well, the reason why it says no error is because it hasn't actually tried the query yet, and there's no syntax error. But that's a logical error. Okay, let's say that I'd put a comma right here. That's actually a logical error. So now it's telling me there's a problem near where you have a comma where you don't need a comma. Something like that. Okay. All right. So test that. Now I'm going to run this. So now I have only those counties that have a population greater than 20K in gray. So in other words, if they're yellow, then they actually have a population lower than 20,000. Okay. So we got the coastal counties, we got these counties through here, and that sort of deal. All right. So that is through where, the where condition. So let's look at the group by condition. The group by condition, it allows us to summarize by a group. Now, I don't know if there's a good group to summarize. Let's see if there is. Properties. Oops, sorry. I meant to look at the attribute table.
How did you get it to show the for the pop counties to show up and have a shape file again? Would that be clickable and turn on and off?
Does yours not show up? That's when I added the geometry column. If I don't have a geometry column, it'll just be a table. Okay, so let's look at the original attribute table, and I don't know if there's a table to group. I mean, there's nothing that really makes sense to group by. Yeah. I wonder if we can.
Could you group it by area? Same size area you want? Could that be a parameter?
Yeah, I mean, what we could create another. You're saying by the area that it is.
Well, you want to be an area guess.
You usually group by like a categorical variable. Does that make sense?
Okay.
Like a category. So we need a categorical variable to group by, and there really isn't one. But I wonder if I'm a little bit fuzzy on my editing in QGIS, toggle editing mode. Okay, so I'm toggling the editing mode. What is this going to do? Save edits, add feature. I don't want to add a feature. I want to add a field. Nah.
You use like percent black, white, something like that. Is that called a categorical thing?
Well, we could create a new table. So that's a good. I mean, so do we have that? Do we have those fields in there?
Yes, they are in there.
So we have white and black. So you're saying what's that? Right. Oh, there is already a % white, % black.
Oh, okay.
Yeah. So Maris added those. We could make a categorical variable out of the other variables by using a SQL statement. Let's see if we can do this real quick. Deliver shapefile. Click toggle editing mode. Open the field calculator dialog. Okay. Let's see. So that was open editor, toggle editing, new field, open field calculator. All right. Create new field. Actually, I just want to create a new field. I don't want to edit it. Okay, so I'm going to create a new field. So I've got my add field. I'm going to call this region. So I have a field called region, and I'm going to make it a, this is in the original county's data. I'm going to make region a, I'll make it a text. Okay. And it looks like I do have to set the length. I wonder if I just hit 0, what's it going to do? Let me see what it does. 0. So now I've got region. So what I'm going to do on the map is using the select tool. This is the select tool right here, I think. Select features. I'm going to select roughly, a third of the state here. So those guys. I can actually close this. It does save what I have listed here. So now I can open up the attribute table, and we're still in editing mode. And I can say that I want to calculate field calculator. I don't want to create a new field. I want to update the field I just created, which is region. And I want to say that the output is going to be south. Oh, or column south, not south. Expression. Yeah, I'm not as familiar with editing in ArcGIS. I mean QGIS. What I want to do is assign these values, the value south. I mean the conversions, general, geometry, string. Here we go, string. I guess you can't just type in something. All right. There's definitely got to be a way to do this, but we're just gonna.
Are you trying to populate region from whatever's in the table?
Yeah, I'm trying to populate region with an arbitrary value that I'm trying to add. So I'm trying to.
They don't give you a list of what's already in the table?
Yeah, this is what's already in the table right here. The table's right there. But yeah, I'm trying to put in a value, and it won't let me just type in, south. That's what I want to do.
Maybe you need to do like region equal to south.
Well, I suppose that's what this is, but region equal to, see, it doesn't, it looks like it only is taking field names.
And the field name got already currently exists. First thing is create a field name out of that.
I mean, I guess I could do like, I mean, this is really clunky, but what I could do is say CO name. I don't even know what language we're dealing with here, but usually, whoops, so it doesn't do dot. Strings.
Can you make a field equal to region rather than trying to do anything? Just translate the data from that field to
Replace. That doesn't like that.
So how do you get all the data from the sound?
Replace string before or after.
Maybe do null equal to south.
So those characters, oops. So, okay, I don't know why those, because I think I'm using the same thing, but now it's working. South. Okay, I don't know why that all of a sudden works, but I thought I was using the single quotes, but now that works just fine. I just copied and pasted it out of the help. So now I can run this, and it works just like ArcGIS at this point. All those say south. Okay. So I can close this, go back to QGIS. Oops. QGIS. And then select all these guys. And then I say open attribute table. And now I have another set of records selected, so I can calculate again, update existing field, and I'll call those middle. I don't know, central. Another quote. Okay, and then I want to make sure, yeah, it's only updating the 28 records. Did it run? Nope. Oh, I forgot to select what field. Region, central, and then say OK. So now they all say central, and then I can go to select features using expression and say region equals, maybe it's equals, no, it's just one. Yep. Select features. Now I've selected no matching features found. Region is not equal. No. Region equals null. Select features. No. Doesn't like null. I don't know how to select just the ones. So I'll just sort them and manually select them. So here's all the null ones. All the null records. And then finally calculate one more time. Say region is equal to quote, north, quote, single quote, and say OK. So now I've got central, north, and south. And I can toggle editing, save the edits, and I can even symbolize them by the. First of all, I want to remove the select features. So I can even symbolize them by that new attribute that I just created. So I go under symbology, and I can change the symbology to be single symbol. I can change it to categorized, and change the column to region, and say random colors, classify, apply. Okay. So now I have my 3 regions, not scientifically chosen, but arbitrary 3 regions. Now I can do what I wanted to do and do an SQL query where I say, I want to find out the population in each of these regions. I want to group by. That's what group by does. Group by says, let's group all of a particular categorical variable together. So what's that similar to? Like we used a tool in ArcGIS to do that, right?
We sometimes with the spatial join, then you can summarize the column afterwards.
Yes, you can do it in spatial join, but on a single layer, you could do it in dissolve, right? We could take the population and then summarize based on a dissolve, and that's basically what we're going to do right now. So I'll go back into my add layer and my where to go? Add edit virtual layer, and notice that it keeps all of your information. So we've still got our last query. So what we can do is let's remove this where clause. Well, no, we could. Yeah, let's remove it. We don't need the where clause because we want to group everything. And so we could say you don't need a where clause. You don't need a group by clause. Those are all optional. You do need the select, and you usually need a from. So we could say group by, and what's the name of the field that we want to group by?
You want to group by the region?
Region, right. So we're going to group by the region. Now, if we try to run this, it's going to say no error, but there's going to be a problem when we actually try to create it. So I'm going to call this population counties. I'll call it grouped. Okay, so I'm going to try to add this, and it looks like it's going to run. But now, look, it doesn't look right? That doesn't look grouped. If I open up the attribute table, yeah, it's just one from each. It's not the correct answer, and what it's actually doing is returning the very first one in each of these columns. In some SQL implementations, it actually throws an error, which I believe is better. When you use a group by, you need to explicitly tell it what aggregate expression you want to use. You need to aggregate your data. In other words, just like a dissolve, you need to tell it how to put them together to get the right answer. And so what we want to do is, we'll get to this in a bit, but the geometry has to have an aggregate. Let's set that aside. Let's aggregate population. What do we want to do? We want to get the total population of that area. There's a function, a sum, yeah. The function is actually called sum. So we put SUM, and now we'll get the population summarized instead of just the very first record. Right? Now, we don't really want to get county name and county seat because now we're dealing with the whole thing. It would be more appropriate just to get the name of the region, right? Yep. So now let's try to run this and see what's different. I'm going to just let it write over the other one. Now notice that we're still going to get the same issue. Oh, I lost my I lost, for some reason this went back. Okay. Let's reset. But one thing we can do is always right click on a particular virtual layer, and we can get the query that came with that virtual layer, and we can edit it. Okay. So see that? All right. So we still got wrong geometry, but if we look at the attribute table, I have to close this though. If we look at the attribute table is now correct. Those are the right numbers. Okay, that's the sum of the population, but the geometry is wrong because it's just getting the first record in that group. So let's modify it. So we also need to summarize the geometry somehow. And there are several what we call geometry aggregates. One of the geometry aggregates is to union all of the shapes. In other words, take all of the shapes and merge them into one single shape. The other option that is commonly used is called collect. And that collect allows us to take a bunch of shapes and put them into a multi-part shape. So I'm going to show you the difference between those two right now. So here is select S, all the spatial type functions are ST underscore collect. And we're going to collect the geometries into a single geometry. So this is an aggregate function for geometries. So instead of returning the first geometry, it'll return all the geometries. And I'm going to overwrite it, yes. So now I'm going to get everything back. Now, you might be asking yourself, that doesn't look any different than the original. But let's look at the attribute table. In the attribute table, we still only have these 3 features. And if I select the north, that's really one feature now. It just has, it's a multi-part feature. You can have, like Hawaii would be a multi-part feature where the parts don't touch. Well, here, it's a multi-part feature, but the parts actually touch. Okay? So it's still just a multi-part feature. It's still just a single feature. That's a single row, and all of those parts are its part.
So did it do like a buffer and got rid of like the county boundaries?
No, if we want to get rid of it, that's what I was going to show you. If we want to get rid of the county boundaries, there's a different aggregate function to use. So here I'll go I'll go back, right click on it and say edit virtual layer. And instead of st collect, I say st union. And what that does is it actually takes all of the features and glues them together into one feature if they touch.
So that's very similar to an actual buffer.
Well, it's similar to a dissolve.
But that's what I meant. Dissolve, yeah. My bad.
So now we have 3 features. 1, 2, 3 features. So if we look at the attribute table now, we get 1, 2, 3 features, and this is the exact same output you would get with a dissolve. So this is the SQL version of a dissolve that we've just done. Okay. All right. The operationally, there's hardly any difference between union and collect except for what it shows you on the screen. Even if you asked it for its area, it would return the same area, right? Like the area of this versus the area of all those little ones added together would be the same. And by the way, that's actually another spatial function that we can include in our query. So we could change the query, and here we've got ST union geometry. We could also get ST area of the geometry. So what this is going to do is it will add another field. I don't know what it's going to call it actually. I probably should have given it a label. So it's calling it ST area geometry. I should have probably said as area. So So now I've got the area column there. So this is the area of that region. All right, so how can I calculate the population density? How can I modify my query so that I also have a population density field?
Could you look at the add field?
Yeah, well, I don't add a field. I can add a virtual field. That's what's kind of cool about this. So right now I have ST area geometry. I'm gonna call this as area. And what I can do is make another field and say sum of P0001 divided by, because in SQL divided by is a slash, that's similar to a lot of languages, divided by the ST area of the geometry. And then I'm going to say as pop den. Okay. So here what I've done is said, okay, I want to see one column that's the union of the geometries. Another column I want to see that's the sum of all the areas. I'm going to call that area. Another column that I'm going to call region. Another column that's going to be the sum of all the population. I'm going to call it population. And then finally, one more column that represents the sum of the population divided by the sum of the area. And I'm going to call that population density. So test this. I just spelled geometry wrong. See, it said no such column geometry. I spelled it wrong again. Geometry. Yeah, I'm a horrible speller. Okay, so I hit.
I feel like their error messages is more clear compared to ARC's.
Yeah, so these errors are actually coming from the database side, and you would get a different error. Like if you did this in ArcGIS, you'd have to have a database, and the error would actually be coming from it'll just pass the error back from the database side. Now, in what QGIS has done, I'm going to get a little techno speak here, but what they've done is they've implemented the SQL-Lite standard into their software, and so it can operate on any geometry that exists. You can operate on any geometry type. It can even operate on a shapefile. So it actually isn't dispatching it out to a database, but it's pretending it is. But still, nonetheless, the guys who wrote SQL-Lite are the ones producing these errors, not necessarily QGIS, because it's still passing it off to that other library. Okay.
Can you symbolize those densities on that map?
I can. I can also show it as an attribute table. So now I've got the population density. I might want to, because right now this is the population per, what units are we in? I think we're in meters because it's UTM. It's Mississippi Transverse Mercator. So this is the population per square meter. And in Mississippi, we don't have a very high population density per square meter, right? Like, in other words, what we're saying is that there's like a tens, thousands, 10,000s. There's a 1/600,000th of a person for every square meter in the north. So if we wanted to actually make that a better number, we could also do that in SQL. We could open the edit the virtual layer. I think we should. So let's do this per square. What do you think? Square miles might be more intuitive for everybody here. Square meters to square miles. Yeah, it's a really big number. Let's go the opposite way. Square miles to square meters. That's a huge number. I wonder what. Well, if we did geometry, so this is the area. You know what? There might actually be a. Let's look in SQL. So this is the help for SQLite area. There might actually be a conversion for. So ST area is the one we're using. It returns the area of S in CRS. I'm just seeing if there's a area, if there's a function for the converting an area. Maybe I'll just Google SQL light spatial light, sorry. Spatial light convert area. Yeah, see there's like conversion functions, length distance unit conversion functions. That's not, we need an area conversion function. So what I'm going to do is I'm going to take the area, and if I divide it by 1,000 times 1,000, I'm going to at least turn square meters into square kilometers. So test, and then hit add. Yeah, I'll overwrite it. So now it's square kilometers, which I know isn't square miles, but at least it'll be a number that is a little bit better. So the density is 681 people per square kilometer, 611, and we can symbolize on it. So we could go into properties, and then under symbology, we could choose graduated and select the column to be the population density, and then hit classify. I'm going to change the classes to 3 because it doesn't make sense to have. So actually, this one right up here is way higher than the other two. It doesn't make much sense to do this with just 3 observations, but we did it nonetheless.
So all the people is up north.
Well, the population density is higher in that particular in that particular region. So it's higher, not a whole lot higher. You saw that it was. They're all about the same. It's just a function of how many layers we had. So up there, the population is 681 people per square kilometer. In the central region, it's 611, and in the bottom, the southern region, it's 592. But we were pretty selective about what we said was the southern region. So there's up here, we're averaging in the Memphis metro area, which has a lot of people, and down here we do have the coast, and like half of Jackson, kind of split Jackson in half. So.
But you have more land in the southern part, you have a larger space.
Yes, a larger space. Yeah, exactly.
Yeah. So when you're talking about region, the number will be about smooth. If you're talking about county, you have dense areas all over.
Yeah, so we actually have, we could go back to that one. So see, let's look at the virtual layer. This is a virtual layer. So here's the query for that virtual layer. So without grouping, we could have another column that represented the ST area for that geometry. And then we could actually do the same thing where we said the population of that county divided by the area another thing, actually, you know that, well, you can actually stack these layers. Okay. So anyway, well, I'll show that in a second. So here's my area, and I want to do it by divided by 1,000 times 1,000. So it's still in square kilometers, but I want to make sure this gets done before the other division problem. So now I can just say test, no error, and then I'm going to add this, so it'll actually it'll overwrite the existing layer. So now I have this counties layer, and if I open up the attribute table, I'm going to have that. Let's rename that column something better. I'm going to call that popped in as pop den. Hit test. Add. Okay. So now I have that extra column that has the population density. Okay.
That's by county, right?
That's by county, and I can symbolize that in the attribute table. Or sorry, in the properties, and I'll get different graduated population density. Classify 5 classes should be good. So now I get that. You can see kind of where the population centers are by county. And I don't know what was the default. That was the method was equal interval. Could do natural breaks. Whatever. Quantiles. So anyway, but that's a virtual layer. We didn't have that field. That field doesn't actually exist on disk. It only exists in this attribute table. And so what's really nice is that we didn't have to create a population density field in our data, right? It's part of the layer. We didn't have to make our data any larger. We just used a SQL expression to come up with that. And what's also nice on disk is you can separate out. Sorry, what's also nice is you can separate out the table that's actually used in the data. So when you share it with somebody else, you don't have to have all those other fields added on there. You just have the fields that you want to include on there.
Is this like a version of RGIS or a lot of this kind of really light, nimble? You might not do as much as RGIS, but it's real quick.
Yeah. Now again, you can do what I'm doing in ARC. You can do what I'm doing in ArcGIS, but you have to have basically additional software installed. You have to set up a whole computer to serve your data out. So that's what an enterprise geodatabase is. Basically it's software that manages all of your tables for you. And you have to connect to it. And then when you ask it a question, the software actually runs on the server. Here, QGIS allows you to run the software locally. So the SQL command is running locally. Now, one reason why this is going so fast is that it's a very small data set, though. So our tornadoes data set is huge. If we were to bring this in right now and do SQL queries on the tornado data set, it would have just as much, if not more, problems than ArcGIS. So I'm not trying to draw a comparison. My point is, I'm not trying to draw a comparison between QGIS and ArcGIS today. It just so happens that QGIS allows us to do what I want to teach today in a better way, particularly in a way where we don't have to install a bunch of additional software. So that's why I'm using
If possible, might go to a place that this all they have, because their budget, there, you might have no
Yeah.
use.
Of course, it's always good to get familiar with another software package. That's totally right. Yep. All right, so you can stack a virtual layer and on top of another virtual layer. So, for example, we already have our population counties here, right? These are our population counties above 21K. So we could go back and add a layer. Add a virtual layer, and then import one of these other data sets. Like I could import population counties, and then I could do an SQL statement just on that one. So I could say, select star, that means everything, from pop counties where pop den is greater than, I don't know what the values are, 220 or something. So now I'm doing a query on top of another query. So if you ever get to a position where you're like, man, I could put this in all in one query, but it would be hard. You can create a query on top of another query. So the population counties is the layer or the table that has population density in it. And so now I can reference that one, and then I can call this pop counties greater than, I don't want to call it greater than 20K, I want to call it greater than 20 people per square km. So I'll hit add, and those are the counties. So not the brown counties. The brown counties are the place with more than 20,000 people. The yellow counties are the counties with greater than 20 people per square kilometer. So those counties are. I think I actually made an error way back here. Just somebody might have noticed this, maybe. This one right here, these numbers are way too big. And I think that what I need to do to fix that problem, let me just see if I can fix it real quick, is that this ST area of all of the geometries, for some reason it seems too big. But maybe I could go st_union of the geometry and then get the area of that. So you can nest. Anyway, even if this doesn't solve the problem, it does show you how you can nest these functions within each other. This actually should be union. So now it'll do that. I don't know. 1,000 times 1,000. Am I doing this? Anyway. Let's look at the attribute table now. Yeah. So those numbers are more reasonable. So I'm not exactly sure why it didn't work. Just because the area of all the little pieces should be the same, but maybe there's something weird. So here. These are the population densities that are the right population densities because we dissolved all the boundaries and calculated the area there. So if we went back to that data set and reclassified it, we'd have to reclassify it and then apply it. There we go. All right, so now we actually get a little bit different answer too. Got the highest population density is here, second highest, third highest. And again, it's really just a function of how we aggregate it. It doesn't tell us anything important. It's just.
So you see the highest and the darkest green?
Yeah, the highest population density. Yep. So that second method ended up being more correct. Again, maybe that would have been a case where it would have been better to create one query and then create another query to make sure that we were getting the right value. So here, to get the right value for area, it was better to union the geometry first, which means to dissolve all the boundaries. I don't know why the number didn't work out not doing that. Maybe the only thing I could think of is that maybe there's some like boundaries that aren't correct, and you can't see them because they're under other boundaries or something like that. But anyway. Also, another thing to think about, one reason why this is so low is because a lot of this is water.
Yeah.
So, all right. All right, let's get back to the slides and see if I missed anything. But now we've done select, from, where, group by. I haven't shown having. I don't even think I have any examples of that. But right now, let me think about that for a second. Order by and limit are really just almost for fun. Like, see how this table right here, if I go population counties, and I look at the virtual layer for it, looks like that. We could modify this so we say order by, and then we could list the name of a field. So we could order it by pop den, and then add that. Now it's going to be the exact same data set, but when we open the table, it's ordered. It looks like in a descending order. It's ordered by. It's actually not even ordered. Oh yeah. Another thing. Remember, I told you that you can't use the name of the fields. Some implementations would have aired out. You can't use the name of the fields that you just created. You have to use the original name of the field. So here we would have to say all this. Now it should be ordered by that. Nope, still not. I wonder why. You can always sort it later. Let's try. Maybe that's just too complicated of a statement for it. I'm not sure. Let's just try ordering it by CO name, because that is in the table.
What does order do? It doesn't say it in the search term.
Yeah, it basically sorts it for you. It sorts it for you so that you don't have to hit the sort button. It's not really that important. So yeah, now is county name sorted? I don't know. Maybe in QGIS's implementation it just ignores the order by. That's what it looks like to me. So ArcGIS doesn't ignore it, but you can always just sort it later. So you just hit these buttons and it sorts it. So what ordered by does is it orders the outputs. So it didn't really do anything. Now what limit should do is only give you the first 10 or 15 records. So you say order by pop den and then limit. Let's see if this even works, because it might ignore it. Add. Yep. Yeah, no, that worked. I don't know why that worked, but look, this is what it did. It only gave us 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they should be the 10 lowest ones, because we sorted by that field. that population density field. So you could also say order by pop-den limit descending and get the top 10. There we go. So now we got the top 10 counties. Those are the counties with the top 10 population densities. If we wanted the top 20, we could do that. They're more for if we wanted to see the tabular information. Okay, so we can open this up, and maybe it is sorting them, but it's not sorting them in this table. See how they're not sorted in the table? But it's sorting them in its brain, and then it's just putting them in the table. It's sorting them in the computer memory. So these are the counties that have the highest population densities, the top 20 counties. That's the way to interpret that SQL statement. So it says, we want those counties, we want to order it by population, and we want to make it descending, and we want to just limit it to 20. Okay. So now we've covered them all except for having. I've been thinking about that for a little while. All right, so one of the things that you might have noticed is that QGIS does prompt us for column names, but obviously if you don't know the columns and the table structure, it's impossible to build a select query. So sometimes it helps to be able to open up and look at a table and see the column names, because you need to know what those are. So you need to know the condition you want to filter, and you need to know the sort order. So you need to know those things in the tabular structure. All right, so let's look at some hypothetical data here. We have a bunch of data, and that data is events, and one of the attributes is the state. So what we could do is say we want to select do a select statement, and we want to have the layer ID column, we want the name column, and we want to select those from a certain table called location. These are locations. We'd say where state name equals Kansas. And then we could order those by name. This is pretty much similar to what we've already done. Okay? In our hypothetical Kansas example, this is how we'd set up our SQL query to answer this question. So usually you think of a question and you turn it into SQL. Okay, so one thing that we haven't covered is dealing with more than one table, or what we call a table join using SQL. You can do table joins, and you can do spatial joins in SQL. There's a method for doing that. And the method is that you include them in the where clause. In the where clause, you specify how you want to join the tables together. So here, we're joining two tables, not spatial join yet. The question we want to ask is, we want a list of locations, IDs, and observers in Kansas sorted by the observer's last name. However, the observer is in a different table. The observer is in a table, and one of the attributes is last name. So we've got location, LID, name. So what we could do is say, okay, I want to find the I want to return the location ID, the name, and the last name from, and then you have to list both tables. If you want to do a join, you have to list both tables to do the join. Okay? So we list location and observer. And if there are any names of your columns that are duplicates, you have to specify which table they come from and use the dot notation. However, in this case, we didn't have that. LID, name, last name, they only existed in one table or the other. But this is how we would have done it to tie them together, where location ID dot lid is equal to observer dot location ID. And that joins them based on that attribute. In other words, any time that those two attributes are equal to each other, put them in the same row in the table. And then this is part of the where clause, this and. So now we're only looking in Kansas, and then finally we're ordering that by the last name. All right, so let's actually do that. To do that, I am going to do. Let's go. I'm going to save this project as Mississippi Census. Okay, and then I'm just gonna. I'm gonna minimize this in case I have to come back to it, and I'm gonna open up QGIS again. You're using a slightly newer version of QGIS on your computers. And what I'm going to do is I'm going to add some of the New York data. So I can go say new, and I've already downloaded the New York data that's in the lab. You can download it if you want. So I'm just going to add it. So I'm going to add vector layers, and mine is located in. I want to get a file. Mine's located in ctemp data. So I want to add, for now, I'm just going to add the census blocks, the socioeconomic data, which is a DBF. So I'm adding the shapefile. I'm adding the socio data, which is just a DBF. There's no other file included for you. And then I'm going to add, for now, that's all I'm going to add. So now I've got those two. I get the same question. I'm going to leave it the same and say close. All right. So I've got two sets of data here. I've got my New York Census socio data and the New York Census blocks. Oftentimes, this is the way that data is delivered, where the spatial data might be different from the attribute data. So here is the census data that I have, and I have a column called BLKID, and then I have a few summary columns, and then I have a column that represents the borough. In my New York Census data, I also have, oh wait, it's tract ID. So I need to get the tracts, not the, did I mess up? Let me see here. Layer, add vector data, census blocks. Streets, neighborhoods. I think I downloaded the blocks and then the tract data. Okay. Or maybe let's see what these numbers look like. Maybe these are the same. That's the wrong data. Census blocks. Okay. How many digits are there? I'm pretty sure. Okay, well, I could probably dissolve these into tracks from blocks maybe even using SQL. But this looks like it's also, but I might have to do some organization. So maybe we'll do that at the break. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, those are definitely different units. Okay. All right. Let me think of some other data that I could join. So I have counties here. There is a county. There is a county code right there. So let's go to Maris. Now, yeah. Actually, let's just continue on here, and we'll do that example, and I'll upload an updated data set to do that example later. All right. So that's how you do a join, though, and I'll do that example later. Okay. So when you do a where clause, there are actually a lot of different operators that you can do. So these are the equal operators here. So we've got this little dash is actually kind of like the bullet. Sorry, that might be confusing. A little dash here. So basically, you could say when you say are two things equal, you just use one equal sign. So it's different than Python. SQL just uses the one equal sign for even for comparison. But not equal is exclamation point equal, and then you've also got your you've got another way to do not equal. But you've also got your greater than, less than, greater than or equal to, less than or equal to. You can actually chain where clauses together. You could say if it meets this criteria and this criteria, then I want to see it, but it has to meet both criteria. Well, you can chain two where clauses together using and. You can actually also do that in ArcGIS, right? So you can say where when you do a select. So what does or do? Well, it makes it so that if either where clause is correct, I want to see it. In other words, if this is true or this is true, I want to see the result. There's a few other things that you can do. You can concatenate or merge two strings using the double pipe operator. You can check to see if something is between certain values. You can also say, is it in a set? You could do that for saying, I want to select all the states that are one of these states. So that might help you. You don't need to use the IND operator to get that. How could you do that with just a logical operator? You could say if state name equals Kansas, or if state name, or exactly, good, did it. All right. So you can use it with a bunch of or statements, but in makes it a little more succinct. There's more SQL than we can cover in one class, okay? But it's well documented, so you can go out there and look at it all. I have a couple of links provided here and on Canvas. So here, if it's null, it should be all capital null to test whether it's null. You can also use the like operator if you're trying to say, I want a certain column to have a word in it. Well, you can use like and use a % sign. You can do this in ArcGIS too. In fact, I don't know if we did it in this class or I did it in my other class, but we did it, I think, within the last 2 weeks. We used the like operator. Here I can go back. Let's see. Yeah, this is still open. So here's my population. Let's see what attributes I have. Oh yeah, I think it was my other class. So here's county name. So if I wanted all the counties that started with a certain letter, I could do that. So I could go to my add edit, virtual layer, and then say select. That all looks fine. Order by population. Let's not do any of that. From counties. Let's say where, CO name, and then you use like, and then you put a quote, and you use the percent as a wildcard. So you say C percent quote. So now I'm going to get all the counties that start with C percent. Start with C. It's going to write over. I'm going to say no because now it'll create a new one. It'll be named the same thing. But these are all the counties that start with a C right there. I could click on them. That's Carroll, Calhoun, Chickasaw, Clay, Choctaw, Coahoma, Claiborne, Copiah, Covington, and Clark. And they could run an analysis to see if they're clustered. That'd be really pointless. But they do look clustered. That's why I said that. So you could use a bunch of different expressions. And again, this class, you actually already, one of the points I'm trying to get across is you already know some SQL just from doing select statements in ArcGIS, and that there's lots of different functions that you can use. So there's functions for pulling out parts of a string, substring, for pulling out those. Here's a few different select statements. So here is selecting out just the first part of a select statement. There are implementations of SQL that will allow you to you can actually run a select statement without selecting any table. I don't think QGIS is like that. Let's see though. So I'm going to go into layer and say add QGIS there it is. So I'm just going to make a select statement that says select substring A, B, C, D, E from 1 to 3. So in other words, it's going to select the first 3 letters, but starting with B, and put them in a new table. Yeah. So QGIS doesn't allow that. ArcGIS does allow you to just put on a select statement, and it would return a table with 1 line that had the answer. So, let me see. Sometimes it wants the yeah, that's not valid. Okay. Sometimes it wants you to put the data type if it's unknown, but yeah, that's not working. Okay. There are SQL implementations that will allow you to just create a single line table and just put in values for your table. But QGIS doesn't let you do that. So you could get all the fields from a table by using the star statement. The only problem with using the star statement is that you can't do the star and other things. I really wish that was the case, right? Like you could say select star, and then you could say comma, and then you could calculate the population density as a new field, right? You can't do that. See what I'm saying here? If I just say select star from counties, from CNTS, then I am going to just copy counties. I'll just call this counties copy. I need my word from. So now I've just made a direct copy of counties, and there's my counties copy. But it'd be nice if you could say, it's P0001 divided by st area of geometry. Let's just leave that as pop 10. And then, let's see what it looks like. Properties. Okay, that works. So ArcGIS doesn't allow you to do that, but QGIS does. So that's kind of cool. I actually really appreciate that. Is the ability to say I want everything, plus I want another field that's the population density. So that's pretty helpful and makes it a lot easier to because if you want everything, you want all the other fields, plus you want a new field, you can do it. And that is actually an easier way than creating a new field, right? Particularly if it's a pretty easy function.
So what you do is select all the fields?
Yeah, so select star means all the fields. And then I said comma, and then I said I wanted the population divided by the geometry. And I could even refine this so that it was that other value. It is in square kilometers instead of square meters.
And what was the output?
The output I call the county's copy.
So what it did is it just copied the same sheet again?
Yeah, so if I open the attribute table, I have all of the columns, plus I have my new population density column.
Which you already had previously created, it added the previous.
Well, I created it in a different data set. So it's in a different virtual layer, but yeah, I had done that before. But I was just showing you what the star did, and then I experimented because I kind of had a suspicion that well, not a suspicion, but I kind of hoped it would work, and I didn't think it would, but I wanted it to, and it did. So that was great. All right. Why is that highlighted? Is that highlighted? Yeah. Okay. Okay. So that's what star does. So you can let's say you didn't change the layer names when you imported them. You can actually change even the location names. You could shortcut those as well. Say from location and call it L, and observer and call it O. You could put an as in between there too if you want. So you could say observer as O, location as L if it's easier to read. That's proper SQL. Yeah. So you can rename columns. You can rename tables themselves. There is this keyword called, it's actually a function called distinct that will take out any duplicates. And then you already saw descending. There's also ascending. So order by 2 here would be order by the second column. All right.
So would you say order that 2 always deal with the field name?
Well, I like to order it by the name of the field, but you can also order it by index, is what this is saying. And I don't even know if QGIS for sure does that. So let's edit the virtual layer. Yep, say order by popped in, which would be, let's test this first. Popped in, and then let's do a descending and say limit 10. So we're going to get the 10 most populated counties. So there's the 10 most populated counties. I've got to turn off the other layer so it's not confusing. So there's the 10 most populated counties. And then let's change it. See if QGIS allows us to implement the column. So it would be, well, I don't even know what column it is. I could just eliminate this.
Can you do a define statement there so they can define all the, we're not looking for, so you can look at them with this, define all the fields and list them up? Is that necessary?
Define, what do you mean?
You know how we did in Python? We like define, we put in a define statement and say everything was in that particular statement.
No, SQL, you can only run one. The way SQL is implemented in here, you can only run one statement at a time. And so you have to look at the attribute table to see what's in the attribute table. So yeah, there's not a way to like execute. You're always adding a new table. Okay. So yeah, that worked. So I said order by 2. What population density was the second column there. So all right. We've got a bunch of aggregate functions. We used some already, but we can also get the min. We can get the max. We can get the average, which is the mean. We can get the count. That's very helpful when we're doing a spatial join. Okay. When you're doing a spatial join, you could get the count, and that will give you the join count that you need. In fact, I wasn't able to do a regular join, but let's demo a spatial join really quick. So just like with a where clause, there's an equal sign. We say where this column equals this column, do a join. So it's the same way you do a spatial join, but you say where some spatial function that evaluates as true or false. So you could say where your geometry intersects, the geometry from table A intersects the geometry from table B, join them together. Do that, right? Or we could say join them if one is inside of the other. Contains or within, they're basically opposites of each other. If A contains B, in other words, if B is inside of A. So both of these would evaluate to be true in this case. But if you said SC contains B comma A, that wouldn't evaluate as true because B is within A, but A is not within B. If you did intersects, either one would be true. Like A, B and A, they'd both be true because they both touch each other. Intersects is a very common spatial join operator. It's used a lot. Touches is similar to intersects, but touches only needs doesn't need to have any area overlapping. So those two are examples of touches. There's a bunch of them. Crosses, distance within. I believe SQLite uses a different function here, but so how could you find out all of these? Well, here is I have that link here, and this has a bunch of statements, a bunch of the SQL functions. So yeah, so functions on type of geometry, st underscore.
So if I'm looking for all the enclave, which is something within something, I'm just gonna say enclave, right? I just got.
You have to use the terminology that's in there. Yeah, so you have to look and see what it is. Intersects is a very common one. So the way this is, what this means is, this is the way to do a spatial join, a regular join, a standard join. this is the way to do a spatial join. What we're saying here is select these columns from A and these columns from B, and then where the geometry from A and the geometry from B intersect. So we're going to do a join. So let's practice this in practice because it's a little bit easier. So I got my counties back up. Go back with this one, and let's get some more data. I think the one that I practiced with was under environmental. Okay, so let's say we want to find out where how many solid waste landfills or brownfields or toxic release inventory sites. Let's go with toxic release inventory sites. So we want to find out how many toxic release inventory sites there are in every county. So I'm going to go C temp. No, that's not where I put it. SQL data. Paste it in there. So now I have these toxic release inventory sites, and I can add those as a vector layer. Choose the shapefile. Okay. So there's all the toxic release inventory sites in Mississippi. And I want to ask the question, how many toxic release inventory sites are there in every county? Okay. I can do that with a spatial join. We did that with a spatial join before. And there may be actually a GUI version of that somewhere. I don't know in QGIS. But this is another way to do it, is to just think about how to write it into SQL. Okay, so here it is. What we have to do, again, is add a virtual layer, in other words, a query layer. We have to make sure that we include the toxic release facilities in our embedded layers. And I'm going to rename it TRI because that's a lot better name. So now I've got my TRA and my counties. So what I can do is, let's think about the columns we want later. Okay, so I'm going to just say star for now. We're going to change that. I have to list both of the two. I have to list both of the two tables that I want to use. So I want to use TRI and I want to use CNTS. So I'm selecting everything right now from both the TRI table and the CNTS table. And then I put my where statement. Where, and then now I use the ST intersects right there. And I say where TRI dot geometry, comma CNTS dot geometry. I spelled geometry right. Geometry. Okay. All right. So I've set up the way that I want this for the most part. Okay. So what I'm doing is I'm doing a spatial join. This is just a raw spatial join where it's going to take any time where a dot touches a county. Anytime where a TRI dot touches a county, it's going to create a new row. So how many rows am I going to get? Yeah, I'm going to get lots and lots of rows because it's actually going to be as long as they all overlap, I'm going to get the multiplicative number of counties and TRI sites. So I need to whittle this down so I don't get that. Because what I really want is just to count up the number of geometries, right? I mean, sorry, just the number of TRI rows. I don't want all the TRI rows. I just want to count them up. And I want to actually display the I want to display the I want to display them all, but I want to display the county boundaries. What kind of join is that, by the way? Which one is the receiving one in that case?
counties.
Right.
Okay,
The counties are the receiving join, and that's what I want to do. Okay, so we're translating a spatial join into a into SQL. So if I just hit test, this is going to work, and I don't know what's going to happen if I hit add because there's going to be two spatial fields. Let's see what happens if I hit add. Oh, see, I didn't rename it. So now it's going to be named something crazy, if it ever even adds it. Well, it did add it. I'm actually gonna delete it. I'm gonna rename it. Oh crud, I lost it, but that's okay. Select star from TRI, comma CNTS. I don't even know why it got rid of that one. I'm gonna add that back in there. TRI, okay. And then where, don't need that comma, where ST intersects TRI dot geometry, comma CNT dot geometry. Okay. So that's what I had before. I'm going to copy that just in case. I'm going to rename this. This will be my my spatial join layer. That's what I'll call it. Spatial join TRI count is what that's what I want to have eventually. Okay. So now I can hit add. CNTS. Oops. Okay. So it's going to take, it's doing a lot of joining. Let me copy this. Okay, so let's look at how many attributes we've got in the attribute table. 94, 188, 286, 382. We're getting, see, it's taking a long time because it's such a complex data set. It says that there are a total of 818. How many facilities were there? There were 818. It should be the multiplication of the two. But in any case, it looks like it's just going to be 818. Okay. All right. So we have all these columns, and they're all of the columns from both data sets. So see, we have region here. We also have all the TRI columns. Okay. I guess that makes sense. Okay. So I was wrong that they would be the multiplicative factor of the two. And I was thinking that they would be like overlapping with other ones, but all the points are actually only in one column. I mean, only in one county, right? It's a point, so it can only exist inside one county. So it's only true. In other words, our where clause is only true one time. And so that's why it's not the multiplicative factor. Okay. But still, we've got 818, and now we've got all the attributes of both. If there was a case where if there was a case where the where clause was true multiple times, then we would have more data in the data set. Okay, so I'm gonna, yeah, I already did that. I'm gonna hit close and open this back up because it's having trouble keeping it there, and now it'll save it. Okay, so let's modify this. So there's 818 records, and we want to collapse them so that we only have one per county. So how would we do that? How would we collapse them so that how would we make it so that, what's the SQL statement?
You want to summarize each county and give it that one particular record?
Right. We want to take our 818 records and we want to do what with them? We want to group them, right? We want to group them by county. So how do we do that? What's the SQL statement for that?
Summarize it.
Well, we'll definitely need an aggregate function that will and we'll need to summarize them somehow. Group by. Right. So you got the second part and you got the first part. So the first thing we need to do is group them by the county. So there's a bunch of different attributes that the county has that's unique to the county. One of them is just CO name, right? So we can group them by CO name. Now, we could optionally write CNTS.CO name. Okay? If we do this, we're telling it we want the CO name from the county's column. There's not a CO name in the TRI column. So we could just delete that part. I'm just trying to show you what the dot notation is for. So it's for referencing which table it's from. See here we said TRI.geometry and CNT.geometry. We needed to put the dot there because we needed to be explicit about which one we were talking about. All right, so we're going to group them by county name. And so now we get back to the part that you were saying, that we need to come up with a way to retrieve we need a way to summarize the data. So instead of selecting everything from these data sets, what we could do is we could say, I want to get the ST union of the CNTS geometry. So that'll give us a good geometry to deal with. So we'll see what will that return? What will we get from the union of all of the county's geometries for that group? Think about it. We have a bunch of county geometries that are so every time that there a point and a county intersect, we have a row in a table. And that row in the table has a column called county geometry and a row in the table called TRI geometry. So we're getting just the county geometries, and so we're getting the geometry. We actually don't even need to do SC union, right? Because SC union is going to take. So this county looks like it has 2 dots in it, right? So that row has a county geometry. That row has a county geometry and a dot. That dot, and let's find one where the dots aren't so close. Well, here I'll just zoom in and we'll be able to see how close they are. Maybe. Come on. It's not running as fast as you thought there. It's running kind of slow. It's because this layer. Let's take out this layer for a second. Ooh, I messed up the. I don't know why that. Okay. Let's see, where group by CO name. All right. So yeah. So select CNTS. What's that?
You kind of make like the field ID or ID for that column.
The county name. What's the county name?
Well, you only got one county name per county.
Right. In Mississippi, there's no duplicate counties. Like nobody says, I'm going to go to Lamar County, and nobody says, which one, right?
Right.
Now, if we were doing this for the whole United States, there'd be a problem because county name isn't unique. You know, there's more than one Orange County. There's more than one whatever county. You're right. We would want to use the county ID, and there isn't a county ID field. It probably would be more appropriate to use that, but I don't know what that name. I don't know the name of that one. So. So here, what we're doing is we're saying, okay, we're going to select the county's geometry as geometry. It's just going to get the first one. That's how it's going to handle that. But what I was trying to explain by zooming in is that row would have a point that represented that TRI, and it would have a polygon that represented that county in that row. And in the row that represented the other point, it would have a point that represented that polygon, and it would have that point, and it would have the same polygon for the county. It would be stored twice. So we could union those together, but since they're all the same, we're asking it to do extra work for no good reason. So let's just get the very first one because they're all going to be the same. All right. So now we're going to have to aggregate. By the way, ArcGIS won't allow you to do that. ArcGIS, what it does is you have to explicitly tell it what you want. If it returns a bunch of geometries or a bunch of layers in here, you have to put an aggregate function to get them together. It won't just give you the first one. Okay. But QGIS lets you do it. Okay, so we want to get the count, going back to what you said before, not the sum, but the count of the TRI dot geometry field. In fact, it could be any field, right? It doesn't really matter but we can get the count of that. And then we want to say that's the count. Okay. All right, so that is the query that we want to do that's going to do the spatial join. And looks like it's taking a few seconds here. Once it actually runs, it'll be faster than the other one because now we've boiled it down into how many records. We've grouped it by county name. How many unique county names are there in Mississippi?
Oh wow! Maybe 100 or less.
Yeah, there's 100 or less. I think it's 80 something. Anybody know?
83. I think.
Yeah, I think that's about right. I was gonna say around 85. It's taking a long time. Maybe there's a button that already says okay. I'm gonna close a lot of these other guys up. Did I lose a button? Sometimes, did I hit test or did I hit add? Anybody remember?
I didn't see it.
I'm gonna close this one down. Let's discard that project. Just to see if it'll. All right. Well, might be a good place to take a break. Anyway, let's just see if there's anything left on this. Whoa! I think my whole computer's like froze. So I don't know why this shouldn't take this long. So I think I confused it by kind of going back and forth a little bit. But why don't we take a break and I'll just X out of it. And there was one more slide where I kind of showed you. I talked about how you implement it in ArcGIS, which is through a query layer. But it won't work unless you have the back end to support it. And then the helps. So I'll go over some of that during the lab. All right, so let's just take a 15-minute break, come back 5 minutes after the hour, and I will have this fixed. Because it should work and it should be going fast. I don't know what my computer is is doing here, but it's all froze up. Hopefully the recording's working.